Astronomers just confirmed something that hasn't happened in over 60 years. A comet from one of the most legendary families in history is about to graze the Sun. And nobody knows if it's going to survive. I know that sounds like a routine space story, but stick with me for 30 seconds, because the numbers here are genuinely unlike anything we've seen in a generation. We're looking at a comet that could outshine Venus, cast actual shadows at night, and blaze across the twilight sky, something the last member of its family did in 1965, and people at the time genuinely didn't know what they were seeing. And here's the part that even the scientists are debating. It's going to pass so close to the Sun that whether it survives or gets torn apart and vaporized is genuinely a coin flip right now. Oh, and there's a second comet arriving just weeks later, an ancient visitor from the edge of the solar system that's also got the astronomy community buzzing. Two comets, same spring, both heading our way. Let's break down exactly what's coming and why April 2026 could be one of the most extraordinary months in decades for anyone who looks up. Let's start with Comet C/2025 R3 PanSTARRS, the first to arrive, and even calling it the quieter of the two is underselling it. It was discovered on September 8, 2025 by the PanSTARRS survey system, not by a human eye, but by an algorithm scanning the sky and flagging a faint speck drifting oddly against the background stars. The orbital data told scientists immediately that this thing has been in transit for tens of thousands of years, launched inward from the Oort cloud, the vast frozen reservoir at the outer edge of our solar system. The Oort cloud is so remote that its objects barely feel the Sun's gravity until something nudges one. And suddenly it's on a journey that takes longer than all of recorded civilization to complete. In fact, C/2025 R3's orbit is slightly hyperbolic, meaning after this pass, it may be ejected from the solar system entirely, never to return. This isn't just a visit for this comet. April 2026 may be its one and only encounter with the inner solar system in all of time. Mark your calendar for April 19th, 2026. That's Perihelion Day, when C/2025 R3 swings to within 76 million kilometers of the Sun inside the orbit of Venus and gets absolutely baked. Then, on April 26th, it reaches its closest point to Earth just 73 million kilometers away, which, combined with peak solar heating, is when observers have the best shot at seeing it. Current forecasts put peak brightness somewhere between magnitude 8 binoculars required and magnitude 2.5, which would make it clearly visible to the naked eye under a dark sky. A phenomenon called forward scattering could push that even further when a comet moves between Earth and the Sun. Sunlight bouncing off its dust tail towards us can temporarily boost apparent brightness by several magnitudes. The new moon falls on April 17th, 3 days before perihelion, so dark skies line up almost perfectly with the comet's most active window. That's a genuinely lucky piece of timing. Northern Hemisphere observers should look east in the pre-dawn sky of late April, tracking through Pegasus and Pisces. Southern Hemisphere gets the evening sky in early May. Neither group is shut out. Now, the honest caveat: comet brightness forecasting is notoriously unreliable. Remember Comet Ison in 2013, billed as the comet of the century. Then it disintegrated rounding the Sun and left us with nothing but dust and disappointment. C/2025 R3 could underwhelm just the same. But the geometry here is about as favorable as it gets, and for the first time in a while. Astronomers are cautiously excited rather than cautiously pessimistic. But all of that, every exciting thing I just told you about C/2025 R3, is genuinely just the opening act, because the second comet is operating on a completely different level. Comet C/2026. A1 MAPS was discovered on January 13, 2026 by a team of French amateur astronomers, Maury, Attard, Parrot and Signoret, using an 11-inch telescope in the Atacama Desert in Chile. Within days of that discovery, the astronomy community started using language you almost never hear from scientists potentially historic, once in a generation, unlike anything since 1965. The reason for that reaction comes down entirely to one thing: the family this comet belongs to. C/2026. A1 is a Kreutz sungrazer, and that classification changes everything. The Kreutz family are comets linked by their orbital paths, all believed to be fragments of an ancient progenitor comet, possibly first seen by Aristotle in 371 BC, that has been breaking apart across millennia. What they share is an orbit that takes them impossibly close to the Sun, so close that the Sun's gravity and radiation test them to their absolute limits. And the ones that survive, they become some of the most spectacular objects ever witnessed by human eyes. The track record of this family is simply unmatched. The Great Comet of 1843 had a tail stretching 300 million kilometers across the sky, visible in broad daylight next to the Sun, without any optical equipment whatsoever. The Great Comet of 1882 was so brilliantly bright that sailors reported being momentarily confused. It looked like a second object rising alongside the Sun on the horizon. Then, in 1965, Comet C, the last great Kreutz sungrazer, blazed to a magnitude rivaling the full moon, visible in daylight, and left people genuinely stunned for weeks. More recently, in 2011, Comet Lovejoy plunged through the Sun's corona at over 1 million degrees and somehow came out the other side still intact, providing some of the most extraordinary comet imagery ever captured. That is the lineage C/2026 A1 MAPS comes from, and based on the early evidence, this new arrival might be the most promising member of that family since Ikeya Siki itself. Here's the single most important fact about C/2026. A1 that separates it from almost every other Kreutz comet we've encountered: it was found extraordinarily far from the Sun. It was detected 81 days before perihelion, at a distance of 2.056 astronomical units, making it the farthest Kreutz sungrazer ever discovered in the entire history of ground-based astronomy. The previous record holder, Comet Ikeya Seki, in 1965, spotted about 33 days before perihelion at 1.11 astronomical units. MAPS almost doubled that discovery distance. That's extraordinary. Why does this matter so much? Because for Kreutz sungrazers, most fragments are tiny, a few hundred meters across at most, and they only show up in solar observatory cameras hours before they vaporize. A comet bright enough to detect from the ground at over 2 astronomical units out is almost certainly packing a substantially larger nucleus, and current estimates put it at possibly up to 2.4 kilometers wide. Size matters enormously here. Because perihelion for C/2026, A1 is an almost unimaginable environment. It will pass just 159,000 kilometers above the Sun's surface, closer than the Sun's own prominences sometimes reach. At that distance, only a physically substantial nucleus has any real chance of holding together, and the fact that this comet was visible so far out is the strongest signal yet that it might have what it takes. Now let's talk brightness, and this is where I have to be upfront with you, because the numbers floating around online range from impressive to absolutely unhinged, and it's worth understanding why. The conservative estimate: based on its current brightening rate compared to Lovejoy 2011, put C/2026, A1, somewhere in the range of naked eye visibility around perihelion, potentially reaching negative magnitudes, meaning brighter than the brightest stars. Some tracking models have projected extreme numbers, theoretical perihelion magnitudes of -10 or even more negative, but these are mathematical extrapolations, not guarantees. And sungrazers routinely break those models. What we can say with more confidence if it survives, it will be a twilight object blazing low in the sky near the Sun for a narrow window around April 4th, before emerging post-perihelion with a potentially spectacular tail. For context, Venus maxes out at magnitude -4.4, the brightest natural object in the night sky other than the Moon. Even a conservative post-perihelion showing by maps could challenge or exceed that. The Southern Hemisphere wins this one decisively. Australia, South Africa, South America, New Zealand, you're looking at the best seats on the planet for what could be a genuinely once-in-a-lifetime sky event. But here's the part that makes this genuinely nail-biting and why even veteran comet observers are refusing to make firm predictions. The perihelion passage on April 4th is an absolute knife's edge. Sungrazers either survive their solar encounter and emerge blazing, or they don't, and the difference between those outcomes can come down to factors we simply cannot measure from Earth right now. There are essentially three realistic outcomes, and I think you deserve the honest version of all three rather than just the exciting one. Scenario 1, the comet fragments or disintegrates before perihelion, which happened to the most recent Kreutz Sungrazer, C/2024 S1 Atlas. Just last year, despite early promise, we'd get a fading cloud and a scientific dataset, anticlimactic, but not rare. Scenario 2, it survives perihelion intact, swings around the Sun, and erupts into a genuine Great Comet tail stretching across the sky, visible in twilight for days or weeks. This is what happened with Lovejoy in 2011, and it would be spectacular. Scenario 3, and this is the one that has solar physicists paying close attention. The comet disintegrates so close to the Sun that its debris interacts with the solar corona, potentially influencing solar activity in ways we're only beginning to understand. We've watched smaller sungrazers dive into the Sun's corona before SOHO has catalogued over 4,500 of them, and while a direct causal link to solar flares remains scientifically contested, some researchers believe large enough impactors could plausibly act as triggers. The scientific consensus right now is cautious. Most solar physicists consider a comet-triggered CME unlikely, but with a nucleus potentially 2.4 kilometers wide. C/2026. A1 is operating in territory where established models may simply not apply. What that means practically, it's a genuinely open question, not a settled one, and that's exactly the kind of uncertainty that makes real science exciting rather than reassuring. And just to round out the picture on space weather, even without any comet involvement, we're heading into solar maximum right now. The Sun is already producing multiple CMEs per day. That's actually part of why April is already on the radar for space weather forecasters. Independently of these comets, the Sun is in an active, energetic phase that's going to produce events regardless. Remember the May 2024 geomagnetic storm auroras visible over London, Paris, New York, Texas, the kind of event that hadn't happened in 20 years, and people absolutely lost their minds over it. We're likely to see several more events of that caliber in 2026, regardless of what these comets do. So if you've never seen an aurora and you've been waiting for your moment, this year in general is your best bet in a decade. But let's zoom out for a second, because beyond the spectacle, these two comets arriving in the same spring is genuinely scientifically remarkable. Both of them are carrying pristine material from the earliest period of solar system formation chemistry that's been locked in a deep freeze for over 4 billion years, untouched by sunlight until now. When they heat up and start outgassing, spectroscopic observations will let scientists read that chemistry like a record, comparing it with other long-period comets to build a clearer picture of what conditions were like when everything formed. There's even a live debate about whether comets like these delivered water and possibly organic molecules to early Earth, essentially seeding the conditions that eventually led to life. These objects are part of our origin story. Think about it this way. C/2025 R3 has been traveling since before modern humans walked the Earth. C/2026 A1 last visited the inner solar system roughly 1,700 years ago, around the time of the late Roman Empire. Both of them have been waiting out there in the dark, moving in absolute silence for all of recorded history, and they're both showing up in the same 3-week window of the same spring. The timing is almost surreal. So here's what you should actually do between now and April, because a little preparation makes a massive difference for events like this. First, bookmark NASA's JPL small body database. It's free, updated constantly, and will have the sharpest orbital refinements for both comets as new observations come in over the next few weeks. Second, sort out your horizon. For C/2026 A1, you want a clear western horizon around April 4th during twilight. For C/2025 R3, look east before sunrise in late April, ideally from a dark site, away from city light pollution. Third, manage your expectations in the right direction. Don't expect a comet filling half the sky, but do expect something genuinely moving if either of these performs anywhere near their potential. Even Lovejoy in 2011, which most people in the Northern Hemisphere barely glimpsed, produced post-perihelion images that were some of the most beautiful comet photographs ever taken. So here's where we stand right now: 2 ancient visitors, 1 extraordinary spring, and a level of genuine scientific uncertainty that makes this one of the most compelling astronomical windows in 60 years. C/2026 A1 Maps arrives first on April 4th, the high-stakes one. The Knife's Edge. The Kreutz family, heavyweight that could be spectacular or gone in a flash. Then C/2025 R3 PanSTARRS rolls in around April 19th, the steadier, more predictable visitor, potentially offering the better naked eye experience if you're willing to chase it. And here's the honest truth: nobody, not NASA, not ESA, not the best comet scientists in the world, knows exactly how either of these is going to play out. That uncertainty isn't a flaw in the story, it is the story. Comets don't audition, they don't care about forecasts, they show up as what they are: ancient, volatile, completely indifferent to our expectations, and we either get to witness something extraordinary or we don't. The spring of 2026 is already circled on calendars from Hawaii to Chile to South Africa. For the first time in a long time, the universe has given us advance notice of something genuinely worth showing up for. Don't sleep on this one. Tell someone, get outside, and whatever happens, you'll be watching the same sky that humans have been tilting their heads up at for 100,000 years, waiting for exactly this. Now drop a comment. Do you think C/2026 A1 survives perihelion and becomes a great comet? Or does it flame out before it gets there? I want to know what your gut says and why.